So in the previous video, if you watched all the way to the end, I said that I was going to introduce you to the opposite of value types in the next video. Well, I decided to change that because I think that computable properties are going to be way more important for you to understand prior to me teaching you about the opposite of value types. With that said, in this video, we are solely going to be talking about computable properties. However, in this, we are also going to be talking once again about value types and so on, just to reiterate the structs, value types, and so on. So let's just get started straight away. The properties that we see in this struct are just like static properties right now. We've defined them with let, or we've defined them with var, and we can give them a default value, and we can give them a value within inside of the constructor, and so on. And so the constant, the let variables, they cannot be changed once they've been initialized. Now, computed property means that they only want to actually be have their value be computed when they're actually accessed. Okay, so what we're talking about here is, I highlighted it in the other video, but what we're talking about here is when we create a person like this, and we'll just say David and Thorn, then we want to have like the full name. Now we could add a method here that say gets full name. This would work as well. This would work as well. And there we could just say with string interpolation name and then surname here. And this will work perfectly fine. Let's just print this out for the sake of showing you here. And get full name. This is a struct method, all right, and this will work. This will work, as you see, perfectly fine. However, sometimes we just don't want to call methods. We want to just have like properties that have their value and they are computed when we actually call them instead. Now, so if we get rid of this one here and we just say instead var, computed properties have to be declared with var, okay? And here we just say var full name. This time we're going to make it a string by default. And remember, any code block with one line on it that has one expression, it will always be the return value. So this is basically saying return here. Now we're going to go into this a little bit more in depth. Don't worry about it. There are some other things that we can talk about. So, and then when we run and print this out, you see David Thorn is once again, and this is what is called a computed property. It means that it contains this code block area and it's going to compute the value of full name when it has been called, when someone actually assigns, when someone actually accesses this one property. So the other thing that we're going to quickly just go into right now is access control, all right? And what we can do here is we can say that we're going to have a private variable, and this private variable is going to be full name, all right? And we'll just set it to nothing in the beginning. Now, what we could do here is we could just return full name, all right? When we add this one private property, you've got to be explicit with adding the constructor because it just doesn't quite know how to initialize the other properties and what should or shouldn't initialize it because we've declared this one private. But when we run it once again, you can see that we can initialize it perfectly fine, all right? Now, when we run this, we still get person.fullname, but full name is empty, right? Because we never set anything to it. So if we want to be able to set this one value, we can't right now because we can't say underscore full name because we're not allowed to access it. Only with inside of the actual struct can we access it. And we've already spoke about mutating, right? So set, let's make a function set full name here, and we'll just say value is string, and so on, and then we'll just say underscore full name is equal to value, which this would be perfectly fine. And now when we say let's just say full name here, before that we'll say person dot set full name, and we'll say David James Thorn. We have to change this to a var because we're mutating it. And we run this again. Now we can see David James Thorn because we've set this one underscore full name property with a string, and our computed property is returning that exact one property. Now, but from outside we cannot access this one underscore full name. Now, we don't actually have to have this one function here. This is the great thing about computed properties. All right, so let's get rid of this function because we can do this in a lot better manner. What we can do is we can say full name here. What our aim is to do is say full name is equal to, right? And we're then going to say here David James Thorne, and I want then this full name to return David James Thorne. So what we can do is we can separate this into two different stages. Is the get is going to say nothing more than return the full name, right? But when we do this, I just want to show you what the compiler is saying. This is like a get-only property, because if we only define the get, then we can't set it. It's not mutable, okay? And this basically is synonymous to saying just return underscore full name. So you don't actually have to write the get. If you just want it to be a getter and not a setter, then you just have to return the value, all right? But if you do want a setter as well, you're going to have to be explicit in this. So in this one code block, this is now going to get called when we then assign a new property to it, all right? Now we can't set full name because that would be setting itself, and then we'd be like in this recursive loop of setting itself all the time. This is why we need this other one property here to say full name is now, you're like, how do I get this one value? Well, it's the new value, okay? It has a property called new value. So now when we run this, you can see David James Thorne, and this one gets set. So if we now print here, setting, right? And let's just say full name here, and say prev new, and then say new value, and we run this once again, you'll see setting prev is blank, and then new is David James Thorne. So you can do some form of computations with this, and we can say like if new value is equal to, and let's say David James Thorne, and make it a lowercase, or let's say if this is not equal to this, then we're going to set it, all right? So now when we run this, we can still see setting and get David James Thorne, right? But whereas if we now put James in here, and now you can see it doesn't set it, and we print out just the empty name still. So this is a great way of being able to work out what should actually be set with inside of your struct and have a little bit of functionality. But from outside, it looks like that it's just a property of the one struct. But from actually inside, you're doing some form of computations, and you've got some form of variables there. Now, we still need to have, because we want it to be mutable, you can't mutate it because that is a constant already, right? And it's a value type. So when we run it with computed properties, as long as it is a variable, we can then change the actual content of that one person, all right? So this is another way of using computed properties instead of functions or methods, sorry, like struct methods. Now, what is the difference? Well, the difference is you don't get any arguments. There's no parameters with the full name with computable properties. All right, you're just going to get the new value, and that is it. But it means you can test it against the old value, and so on. And you can also do some form of if you could also do some form of computation for other things. If every single time something gets incremented, or everything sometimes something gets set, you can increment something a counter, or you can tell it to do something else, and so on. So there are a whole bunch of great things that you can do with this. Now, there's another thing that we can do. If you want to move this out, right, to an extension, this is also possible. And this is another area where you would have computed properties, all right, is by saying we're going to extend person, and here we're just going to say var full name, and then string, and in here we could then just say underscore, or we could just say here name, and then here surname. And we run this once again, you can see we can't set it because we're only having a getter here, right? So if we now do this, and we'll say what we just, whoops, let's just paste that in there, it's far easier. Let's take this out, put this in there, and run this, we get exactly the same. Sorry, I just built it. If we run it, and we get exactly the same thing once again, and if we change this to actually David James, it will output what we wanted because we stopped it from setting with a lowercase James here. So this is now introducing you to extensions as well. And you can see here how within inside of the extension, we can still access this one private property, right? Now, so I don't really want to get into this, but these are all internal, all right? All of these things here are saying basically internal. If it's not displayed, it means it's internal, all right? And there's open and public, but we're not going to get into that. I just wanted to show you how to have some form of privacy. And it's kind of like a coding standard that when you see an underscore in front of the property within inside of a struct or a class or something, I haven't talked about classes, then it's indicating that it is a private property and it's there for the sake of computable properties and so on. With that said, I hope that you've got something out of this one video. You will see computable properties a lot when you use Swift, and you should use them as much as possible if you need to compute some form of value within inside of the struct. If you can't, then you need to use functions and so on. But if you don't need any parameters in your code, if you don't need any parameters, then I would always think about using a computable property rather than a function or a method. I keep saying function, but a method, all right? With that said, thank you very much for watching. Don't forget to like, subscribe, share, and do all the other social media things out there. And if you've got any questions, feedback, or concerns, or critiques, then let's start a conversation in the comment section down below. With that said, thank you very much for watching. My name's David Dawn. See you in the next video. Ciao, ciao, and goodbye.